Okay, thanks. All right. So today, here's what we're going to be doing. We're going to intro section 4.4. So this is the new section. We have never seen this stuff before. It is proving that triangles are actually equal. Not just given that they're equal, but proving that they're the same exact triangle. So today, we're going to intro it. Tomorrow, we're going to do more of a hands-on activity in class. So tomorrow will be kind of a little fun activity. I kind of like it. So it uses some of the construction tools and whatnot. So we'll do that tomorrow. So be kind of prepared for that. We have homework assignment due tomorrow. If you're not aware, that was the worksheet 4.3. It was worksheet 4.3. So it was based on finding x, finding the missing variables, assuming that every picture I gave you was equal. Every triangle or every shape, whatever the shapes were exactly congruent to each other. You can find the values of the variables for every one of those problems. I'm going to do one example today, something that came up yesterday that was really stumping people, and I'll just kind of make up a problem as we go, just so you can kind of see it. All right, so just so you're kind of aware of that. But yeah, so let's go through two notes here. I got two slides, two postulates I want to talk about today. Postulate 4.1 and 4.2. And remember what a postulate is. If you don't remember, it is a mathematical property in geometry, right? It's a property of math that we accept as truth. We don't prove it. We just accept it. Now, I'm going to show you why it works tomorrow. That's the hands-on. Because sometimes you get to these postulates and you're like, how does that even work? Like, how do you know that's true every time? That's what we're going to look at tomorrow. We're going to look at the hands-on activity where you actually get to mess with it and see that it actually works every single time. So that'll be kind of the fun part, and I kind of like doing that. So that'll be the in-class activity we do tomorrow. That'll be something I actually grade. So it's part of the Google classroom activity we'll do tomorrow. So I'll probably put that as an activity and I'll submit it. So, all right. We ready to go though? Everyone's got notes? It's a pretty easy day, so let's jump right in. So here's our first slide out of the three that I want to cover today. So it's postulate 4.1. It's called the SSS postulate. If it says, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are exactly congruent to each other. So good timing, Marley. So, but yeah, so this is a brand new postulate. Again, we're in the new section 4.4. It's trying to prove that triangles are equal. I'm going to go to a different mask today. I don't like that one. That's a little old. I think I shrunk it when I washed it. Let's see if this one's a little bigger. Oh yeah, much better. I gotta shrink my yellow one. So, three sides of one triangle are equal to three sides of another triangle, then the triangles are equal. It's a postulate. We don't prove this. We accept it as truth. We'll talk about it here. So I provided you two triangles there, so ABC and XYZ. And we'll mark these here in a minute. Again, it's a postulate, so we're going to accept it as truth, and we'll look at it tomorrow. So again, that's the in-class activity we'll do tomorrow. We'll actually look at why does this work every single time. How do you know? All right. All right. So first of all, I'm going to ask for some volunteer parts here. So first part here I'd like somebody to volunteer for is to pick one of the walls on triangle ABC. Pick any wall you want, just give me one of the walls. So somebody just say one of them. AB. Okay, so I'm going to mark that AB. I'm going to mark that as the one. That's the first one we said. So now down here on this other triangle, pick one of the walls on the XYZ triangle, any wall you want. XZ, is that what we said? Okay, XZ. Okay, there we go. So what we have here is that we have one wall and one wall. Okay, now let's go after the second wall of the triangles now. Let me mark that a little bit better. That was a terrible marking. All right, now let's pick a second wall now. I'll pick a different color here. Pick a different wall on ABC, any wall you want. CB. Okay, I'm going to put that as a 2 marker. Let's pick another wall down here. Any of the walls down there except for the XZ, I guess. Any different wall. ZY. Okay, we're going to pick a ZY. We'll pick that as a 2. And then obviously our third wall would be the final one. So if 3 walls of one triangle are congruent to 3 walls of another triangle, the triangles are equal. So now, this is the part I want you to understand, right? We're given that the walls are the same, right? AB is congruent to XZ, and ZY is equal to BC, and you get the idea. And then obviously all the walls are the same, and it forces the triangles to be exactly the same. So the part I want to figure out, this is the hardest part, is how do you write what's congruent to each other? So obviously I have to write, triangle something 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 is congruent to triangle something something something. I need the letters in some particular order. So if we go up there to the triangle ABC, or whatever you want to call it, you have to pick one of the letters and spin clockwise or counterclockwise, but you can pick any letter you want. So start on any letter on that top triangle. What angle do you want to, or what letter do you want to start with?
C.
C. Okay, now do you want to go clockwise or counterclockwise? So we're starting with C. Do you want to go clockwise or counter? Counterclockwise. Okay, so we're going to start with C and write BA. CBA. Okay, that's the triangle up above. Now, here's how we did it. We started here, and we went around the triangle going this way to C to B to A. So I went across the yellow and then up the pink side. So on the other triangle, where do I need to start to get the letters in the same exact order? Yeah, I have to start with Y, go across the yellow, and then go up the pink wall to X. That's the hardest part. You have to have the letters in the exact right order. I had to start with Y. That was the first letter I heard somebody say. You have to go across Z and end with X, because you have to go in the same order that you did the other triangle. I went across yellow, up pink. Cross yellow, up pink. It's no longer a free-for-all, pick any letter you want and just kind of write it up there. You have to go letter for letter. Now, another way to do it is just to figure out the angles. So like, for instance, you guys picked angle C first. Well, that angle is in between the yellow and the blue wall. So that's in between the yellow and the blue wall. So I go find the angle that's in between yellow and blue, that's angle Y. So that had to be the first letter. Maybe that's a better way for you to think of it. Maybe you don't like using the wall colors. Maybe you just need to look at where the markers are. It's in between 2 and 3. So I started with C, so I start with Y on the other triangle. And then the next letter I wrote is B, which is this angle. That's in between the 2 and the 1 marker, so 2 and the 1 marker, that would be angle Z. Does that make sense now, how I did it? Maybe that's a better way for you to think of it, instead of using the wall colors. But they have to be in order. You can no longer just, randomly pick. All right, questions on the first postulate? Okay, second postulate, here it is. Postulate 4.2. This is our last major property today. We'll have more later with the later sections. I think the next section has some more of these, some more properties, theorems and stuff. It's called the SAS postulate. So I'll read it aloud, and then there's a word I want you to underline in the middle of this paragraph, and I'll underline it here in a little bit. But here's what it says. If two sides in an included angle of one triangle are congruent to the two angles in an included angle of another triangle, then the triangles are congruent. Now, the word I want you to underline as you write it. I want you to underline the word included. That word means something different than what you think it does. I wish they would have used a different vocab word there instead of the word included. This is how every textbook writes it, so. Again, it's a postulate. We accept it as truth. This is, again, a part of the activity we're going to do tomorrow in class to talk about this. Now, the word included, I had you underline that word. The word included. A better word that I would have used instead of the word included, I would have used the word in between. I'll use the word in between. You have two walls, and the included angle means the angle that's in between the two walls you pick. So if you pick any two walls on a triangle and you pick the angle in the middle of them, that's the bare minimum information I need to prove that the two triangles are equal. Like on the last postulate said, if you're given the three walls, it forces the triangles to be exactly identical, right? The angles ended up being the same, everything. On this one, I need two walls. So on the top triangle DEF, I need any two walls up there. So pick two walls in that top triangle. Pick one of the walls. DE, okay? I'm going to put a marker there. So DE, there's one wall. Pick another wall. EF, okay? So EF. Okay, so here's EF. And then we're forced to pick the angle in between them. The included angle, that's what they say. The included means the angle in between the two walls you picked. So if that works out, where you're given those markers, and those markers match the other triangle, I don't care how, but somehow those markers match perfectly with the triangle down here. You have two walls marked and the angle that's in between them. Then the two triangles are exactly the same. That means the third wall has to be equal. The two other remaining angles have to be the same as well. By just those bare minimum markers, 3 pieces of information can tell me that I have the exact same triangle. All right, now, again, just like before, you say the triangle in any particular order. So if I sit on that top triangle, DEF, I'll just put it in that order. How is that equal to the bottom triangle? What letter do I write? So I said DEF. How do I write the bottom triangle? NOM. Yep. NOM. Again, how we know that? I hate my palm keeps putting swipes on there. How you know that? I start with angle D. That's it's going along the green or along the single wall. Then it gets to the angle marker. Then I go across to the two wall. So I start on the single wall, go across to the angle, and then up the two wall. So N to O to M. It's I use the wall markers and the angle markers to help me out. So I went down to D to E, and then across to F. So from N to O, and then up to M. So, and it has to be in that order. You cannot put them in random order. See you, Doug. Good luck today. Good luck to you. So, I don't know if you have to check out in the office, so make sure you talk to them. Okay.
It's in the school.
Okay. All right. All right. Questions with this postulate? Again, it's a postulate. We accept it as truth. Now, what you're looking at here, like why we've been doing these, this is the bare minimum information I need on a picture to say that, yes, these triangles are identical to each other. I don't need everything marked. I don't need every angle, every wall marked. I just need bare minimum information. The last postulate, it said that I just need the 3 walls marked. On this one, I need 2 walls, the angle in between them. And it forces the triangles to be identical to each other. So that's something I want you to be aware of, that we're getting into parts where if I was just given select few markers, I can make extra marks now. If I saw these markers, I can now mark the 3rd walls, I can mark the other 2 angles. And I can go from there. That everything has to be identical to each other. That's what it's getting me to. That's the tough part that you have to wrap your head around. Okay, questions with the 2 properties though. Okay, last slide of the day. This is the one I want to talk about today. I'm just going to make up 2 pictures here, just so you can see this. This is something I want you to be aware of. Okay, so let's say that. In fact, I'm going to get rid of these. I don't like these pictures. I'm going to use pictures that were kind of that you guys were using in the book. And there was one problem that looked something like this, where it was a right triangle. Then there was another picture over here, same thing. It was a right triangle. And then they gave you certain walls. So, for instance, so this is like x plus 4 and y minus 2, something like that. And this was a, let's say this is a y plus x or not y plus x, y plus, let's go y plus 7. Ooh. Y plus 7. And let's say, let's see. Okay, so let's see if I want to do it as, let's see. Say it was something like that. Whoa. Something like that. Okay. Okay, so this is something I want you to be aware of. I'm not going to solve this problem all the way out. I just want you to be aware of something when I have it written here. So here's the idea. This is a system problem. You had to identify which walls were supposed to be equal to each other and set them equal. So like for instance, when I look at these two pictures, I have no idea why I switched colors. I go from yellow to orange. I just noticed that. Anyway, on this problem, what two walls would you say are equal to each other by just default when you look up there? Pick any two. What do you got? What do you think? Pick any two walls. Which two?
Bottom.
Okay, bottom right. So that's this one over here. So bottom to the right side. And what is that equal to on the other triangle?
X plus 4.
X plus 4. Okay. And so I'm not going to solve this one out, but what you do is you would set those two equal to each other, right? Every picture in your homework, was meant to be congruent to each other, right? I said that yesterday, that every picture was congruent. You had to just figure out how to set them equal to each other. So to solve this, I would, subtract that across, move the y across, so x minus y, subtract the 4 across, so this ends up being x minus y equals 3. Okay, so I've rearranged this equation to make it a system, just by rearranging it. You have to know that you can do that on a problem. You can rearrange it. Some people are really getting stuck with, how do I even start the problem? Like, they don't have the letters in the same spots. It's probably a system where you have to set up, like this is one equation. You have to set this up, and then you have to go look at the other parts and set that one up as well. So just be aware of that. Some people were really getting, I think, thrown off by that yesterday. So just be aware. Okay. All right, questions with how to like set like one of the equations up or the other one. Okay, I just made it up on the spot, but okay. Now, does anyone need me to finish this out just so you can see it, or are we comfortable with what you have here? Okay, so again, I just set up one of the equations. You would set up the other two walls and you do the same thing. That was something that I noticed a lot of people had questions on yesterday. There was one question in particular that you had to do something very close to that. You had to set up a system. That was just one equation. I have to do the other two walls now. Okay, all right, I'm going to stop there. You guys can work on your own. We have homework due tomorrow.